In this video, we continue to consider a generic risk assessment process. In this part 2 of 3 parts, we will address the central role of evidence in the generic process. As the very handsome gentleman says, in part 1 we learned how to decompose consequence and probability into their component parts. Here, in part 2, we'll talk about the evidence. Recall the glimmerous example of an aquatic nuisance species becoming established in a new basin, where we identified 3 broad categories of consequences: economic consequences, environmental consequences, and other consequences, and 5 events that are necessary for any or all of these consequences to occur. The next output in the generic process is to rate the risk potential for each of the 3 consequences and 5 probability elements. Because this is a qualitative risk assessment, these ratings are non-numeric and categorical. Common categories of ratings are high, medium, low, none, or one could use 1 star to 5 stars, or some similar groupings of risk potential. The thing that will make or break the quality of your risk assessment is not whether you assign an H, M, L, or an N to an element, but what is the quality of the evidence that you use to support the rating that you choose. Evidence makes or breaks your risk assessment. Let's make sure we have a common understanding of the word evidence. The Merriam-Webster Online Dictionary provides this definition: evidence is something which shows that something else exists or is true. Evidence is a visible sign of something. Evidence is material that is presented to a court of law to help find the truth about something. For the purposes of this course, evidence includes science, data, facts, information, and all such forms of proof, confirmation, and corroboration. Basically, evidence is anything that helps to reveal the truth. You will often hear risk analysis and risk assessment described as science-based processes. I prefer the term evidence-based to science-based simply because it's more inclusive. Some people would not consider data and some other forms of information to be science, but we can all agree it is evidence that points us to the truth. Let's take a look at the ratings for the 5 probability elements, describing the likelihood that the silver carp will cause adverse consequences in the Great Lakes Basin. The probability a pathway exists is high because anyone can see that it exists. Boats, barges, and ships use it on a daily basis. The evidence is incontrovertible. The probability the silver carp will arrive at the pathway is also high. Routine monitoring of the Asian carp in 2009 confirmed sighting of a silver carp at the confluence of the Chicago Ship and Sanitary Canal and Des Plaines River. The probability that the carp will successfully pass through the pathway is rated as low for the next 10 years, although there's a good deal of uncertainty attending that rating. This is because, first, small Asian carp are not expected to be present at the electric dispersal barrier system. Second, the abundance of adults is expected to be absent or low near that electric dispersal barrier system. And third, if a low population of adults approaches the barrier, then it is expected, based on current research, that the barrier would be effective at controlling passage of these fish. The probabilities of colonization and spread are both high because although some bioenergetic models suggest that in general productivity in the Great Lakes Basin may be too low to support Asian carp, including the silver carp, there are several areas of high productivity within the Great Lakes Basin that are likely to be suitable for supporting this species. Therefore, if the carp is able to pass through the Chicago area waterway system, it is expected to colonize and spread through the Great Lakes Basin. If you'd like to see the nature and extent of the evidence used to support these ratings, see Appendix C of the Glimmerous Report. Silver carp information is found in pages 19 through 25. Just to emphasize the importance of the evidence used for qualitative ratings, here's a short excerpt chosen from a citrus canker in oranges risk assessment that was conducted by the United States Department of Agriculture's Animal Plant Health Inspection Service. Don't worry about the details of this assessment. This excerpt describes an event of concern to risk managers. It then provides a conclusion for the event and supports that conclusion with specific evidence. All of this leads us to an important and inevitable conclusion. As a risk assessor, you must gather, organize, and use the best available evidence, because without evidence your ratings are meaningless, and meaningless ratings render your risk assessment worthless. Failure to adequately support qualitative ratings with evidence has given qualitative risk assessment a bad reputation in some instances. We are far from finished considering the importance of evidence, however, until we have thought about the importance of not having enough evidence to answer the risk manager's questions or to characterize the risk as confidently as we would like. One important question we must consider is, what if the evidence is limited, conflicting, or we are just not sure? In this case, which almost always arises, we must be honest and say what we do not know and what we do know. One way to do this is with uncertainty ratings, or their opposites, confidence ratings. Here's an example of some confidence ratings prepared by the U.S. Army Corps of Engineers. Confidence ratings are often more intuitively appealing as a way to express uncertainty. But let us be clear about the inverse relationship between confidence and uncertainty. High confidence means low uncertainty, and low confidence means high uncertainty. Our ratings here are described as follows. High indicates that the nature of the issue is knowable, and there is consistent evidence supporting the judgment from a variety of credible, independent sources, or that the evidence, though limited, is measurable and consistent with accepted physical principles and scientific methods. Inferences are few, and there are no apparent plausible alternatives deemed as likely as the judgment. A high confidence judgment is not a certainty. Medium indicates that the nature of the issue is either knowable or sufficient evidence minimizes uncertainty. Although there may be minor inconsistencies, gaps, or questions, credible evidence largely supports the judgment. There may be some foundational assumptions or inferences, and a plausible alternative deemed nearly as likely as the judgment. Low indicates that the nature of the issue may not be knowable, for example, complex future-oriented judgments. Or there are significant inconsistencies, gaps, or questions regarding the evidence. There may be several foundational assumptions or inferences, and a plausible alternative or alternatives deemed as likely as the judgment. You may use these or develop any reasonable definitions you like. For contrast, here are some uncertainty ratings taken from the Glimmer study, pages C21 and C22. High uncertainty means there are little or no data available, and the probability rating, as well as all assumptions used to develop that rating, are based on best professional judgment. Medium means there are some good data, but there are also some significant data gaps, such that the probability rating is based on a mixture of aquatic nuisance species-specific data, data from similar species, anecdotal data, and professional judgment. Low means there are good aquatic nuisance species-specific data available, for example, peer-reviewed aquatic nuisance-specific scientific publications and reports, and no significant data gaps are known. Finally, A rating of no uncertainty means all relevant facts are known and there is no uncertainty. To illustrate how uncertainty ratings can be communicated to others, here's a summary of the risk assessment of the silver carp taken from the Glimmer's study. Notice there is no uncertainty about the first two probability ratings. Uncertainty is high, that is, confidence is low, for the passage probability rating as we look further into the future. Meanwhile, the colonization rating has a medium uncertainty, and the uncertainty about silver carp spreading if they colonize is low. Also notice there is no overall uncertainty for the probability of establishment. The Glimmer's team judged that there was no objectively consistent way to aggregate the overall probability of establishment from the 5 separate element ratings. Breaking a risk down into its component parts is the basic logic behind the generic process. But rating these elements qualitatively on the basis of the best available evidence, and then communicating the degree of uncertainty or confidence about those ratings, makes those judgments the heart and soul of the generic process.